Good morning students. Today we are going to have a lecture related with the VLSI concept. It's a low power VLSI. So under this we will be learning about the introduction and how to go with the low power design, what all the technologies we need to employ. So unit 1 coverage, it is related with the power estimation analysis for low power design. So low power, it's going to be the current area where the current trend, it is for the power consumption for all the electronic products, which is going to be very less expensive when it is considered for a high-end design process. So newer generations of semiconductor processing with respect to increased device density, speed and complexity. There are a lot of problems which would be broadly classified under the VLSI terminology. One would be with respect to analysis and then optimization. So when we go with this, the need is going to be for major demand for low power chips, and it comes from the environmental concerns for high performance computing system, which is a need of an hour. So here, steady growth with respect to the operating frequency. Whenever the frequency increases in the capacity per chip, there should be an increased power dissipation which will happen, and this dissipation has to be controlled, and this is going to be the concept of low power design. So in this, charging and discharging capacitance, it plays a vital role. So dynamic as well as static power dissipation, these two are the concepts related with power dissipation. In CMOS logic, leakage current is the only source for static power dissipation. Dynamic, it is related to the switching activity of the design process. So static and dynamic, it goes one after the other. Equivalent circuit related to the inverter concept, where the transistor is replaced with a resistive component RC as well as RT, and the charge which is going to be accumulated at the capacitor, which is a charge storage device, and what would be the voltage whenever it is connected as a switch, and VDD is going to be the voltage. So with respect to that, the equations are related with IC of T, which denotes CL dV by dt, and energy which is going to be drawn from the voltage source. We had a voltage source with respect to the circuit as VDD, and that is related with the equation of T0 to T1, which is a time instant where voltage and current is going to be multiplied. And during this charging and discharging phase, we come across the equations of ES, E cap and ED. So there are three different terms which are related with that. So capacitance storage related with half CLV squared, and dissipated energy, it is half CLV squared, and what is going to be drawn from the source, that dissipation is CL into V squared. So with respect to that, the power dissipation concept is well understood. Es into F is the frequency of operation. So every VLSI chip, which is going to be a digital or an analog chip, the design is related to the power dissipation, where total power dissipation is given by C total V squared of F, where the summation is related with the accumulation of the charge at the capacitance part, and that is the C total of it. So with this, we come to a conclusion of what would be the total power dissipation of an inverter circuit, and all these equations are related with capacitance, voltage and frequency. This would be the golden equation which would be of concern related to the next design process. So thank you.